Friction welding. What is friction welding? Friction welding is a solid-state welding process that generates heat through mechanical friction between workpieces in a relative motion to one another. This process is used with the addition of a lateral force called upset to plastically displace and fuse the materials. It is a similar process to forge welding. Friction welding is used with metals and thermoplastics in a wide variety of aviation and automotive applications. Applications and patents connected to friction welding date back to the early 20th century.
There are three different types of friction weldings. The first type of friction welding is rotary friction welding, where one component is stationary while the other component is rotating. During this process, the two pieces are pressed together via compression until the parts are completely welded together. The second type of friction welding is linear friction welding, where one component is stationary while another component is rubbed against the surface of the stationary component in a linear motion at high speeds until the two parts are welded together. The last type of friction welding is friction stir welding, where an external pin tool that spins is pressed into the material so that it can first soften the metal piece at the welding interface, and then once at an optimal softness, it moves along the path of the weld interface, joining the two pieces together while retaining the material's original properties. When completing the process of friction welding, there are a few things that need to be kept in mind. One item to keep in mind is that the material needs to be both compatible with each other as well as the friction welding process. Metals with similar properties can be friction welded together, but materials such as polymers and thermoplastics cannot be used in the friction welding process. Another item to keep in mind is that the surface of the material that is being friction welded has to be a clean surface. This means that the surface has to be free of any dirt, oil, grease, and oxides. Proper surface preparation is critical for creating high-quality welds.
So why is it used? The rapid relative movement and the heat generated between the parts displaces/burns impurities in the weld, creating welds that are just as strong as the parent material. Furthermore, the similar materials can be welded together without the need for filler material or heat flux, meaning fewer fumes are created during the process, and it could be automated.
Why is it not used? It comes at a high setup cost, requiring rigid and heavy-duty clamping equipment, which could also require augmentation of the workpiece for fastening purposes. It also requires a large axial or downward force for the weld. Rigid and heavy-duty clamping equipment is required to hold the workpiece, and some augmentations may need to be made to the workpiece. A large axial force or downward force is needed for producing the weld, and the weld design can be limited and it comes at a high setup cost.